Hello, this is Mr. Gilmore with the 6.3, the Triangle Midsegment Theorem. This is the grand finale of our semester. We're going to see how we can take everything that we have really learned this semester and compile it into one theorem. It is a bit of a tricky theorem, which is why I'm going to guide you through it. Let's jump into this. First, we need to understand what is a midsegment of a triangle. Well, a midsegment of a triangle is a segment that joins the midpoints of two sides. So in our diagram below, we have triangle ABC, such that D and E are both midpoints of sides AB and BC. When we connect the midpoint D to E, that segment that's formed is known as then the triangle midsegment. So something remarkable happens with that midsegment. There's going to be two results that we're going to prove about that midsegment DE. The first thing we're going to prove is that DE is actually parallel to the third side that it does intersect. And it also measures half of the length of the third side that it does intersect. So in other words, DE is going to be parallel to AC, and that DE is half the length of AC. So the setup of our proof looks like this. We have triangle ABC such that DE is a midsegment of this triangle, such that D is a midpoint of AB and that E is a midpoint of BC. With the diagram at hand, we are going to prove that DE is in fact parallel to AC and that it measures half the length of AC. So where does our proof begin? It actually begins with a construction. Let's take a look at that. So where this construction begins is actually taking the midsegment, DE, and measuring it. We're allowed to do, with the ruler postulate, measure and make measure. So we measure the length of DE, and we extend our segment, DE, through point D to a point F, such that the length of DF is the same length as DE. In other words, DF is equal to DE. So I've marked those as equal on our diagram as well. Then lastly, we connect point F to point A, and we get this. So we've adjusted our diagram a bit with this new construction. Well, as it turns out, with this construction, we are now able to prove that DE is going to be parallel to AC and that DE measures half the length of AC. Now, I'm only going to give you an overview of this proof. On the worksheet is where you're going to find the details, and this is going to be guided. I have set up all of the statements. You give me the reasons for this. But in this overview, I'm going to point you in the right direction of where you should be going. So part A, in our diagram, the first thing we want to do is prove that triangle DBE and DAF are actually congruent to each other. Now you'll already notice that we have one pair of equal sides here, that was given, and we have these three sides here, or these two sides, DE and DF, right, by our construction are equal. Well, the two segments there, because ED and F are collinear and ADB are collinear, we actually have a pair of vertical angles. So that means we can immediately prove that those two triangles are in fact congruent by side angle side congruence. So one of the reasons you'll definitely use in your proof is side angle side, along with definitely vertical angles theorem. Good old theorem, right? Saving us here in this very last kind of grand finale we've got. Now we want to prove is that AF is equal to EC and that AF is parallel to EC. So where we begin is using our best friend CPCTC, because our best friend says that corresponding sides have got to be equal to each other. In other words, AF, if you notice, is equal to BE. Look at that. But remember, E is a midpoint, which means BE is also equal to EC. Look, we can prove AF is equal to EC very quickly with CPCTC and transitivity of equality. So we've got that one, check. But how do we show then that AF is parallel to EC? This is a little bit a trickier one to see. With our congruent triangles again, okay, so go back to our congruent triangles, there's actually a pair of angles that we know to be equal. Take a look at angle DAF and angle DBE. Those angles we can prove to be equal by CPCTE. But they have another relationship. If you take a look, those are alternate interior angles. If AB is the transversal and AF and BC are the two sides, or the two lines, that means those two lines have to be parallel to each other because of the alternate interior angles consequence. Alternate interior angles test. So using some of our parallel properties from chapter 4, we can actually prove that those lines have to be parallel. What does that mean? That means we know AF will be parallel to the side EC. Now, why is that important to us? because there's something now special about this quadrilateral, AFEC. That quadrilateral has a pair of sides that are equal and parallel to each other, right? A pair of opposite sides that are equal and parallel. What now is true about that quadrilateral? It is a parallelogram. We can prove that. We did prove that. This is one of the parallelogram tests. So we know that AFEC is actually a parallelogram. And because it's a parallelogram, we can now use the parallelogram properties. In particular, here's one of the properties we want to use. Opposite sides are parallel. That's the first thing we want to say. Hey, we know opposite sides are parallel because it's a parallelogram. And another property about parallelograms is that opposite sides are equal. And that's another step we can take. So when you jump over the 6.3 worksheet and take a look at the triangle midsegment theorem, you're going to encounter the two-column proof. It's going to have the statements filled in there for you. You fill in the reasons. There's a lot of information above that two-column before you jump into it. Make sure you read through that information. If you do have any questions on this last worksheet, please do not hesitate to ask me. With that, be good and do good.